Hello again, everybody, and welcome to the final video in the linear function series. Today we're going to look at general form for a linear function, or a linear relation. So that's important, my little slip up there. This is for linear relations, not just for linear functions. So some basics about general form. So first of all, general form has this form right here. ax plus by plus c equals 0. So you can see it's definitely different, right? Everything's on the left side. The A, B, C are integers, okay, so whole numbers, no fractions, no decimals. And the A always has to be positive, okay, so you can't have a negative number in front of that x value. So here's what one could look like. 2x plus 3y plus 5 equals 0. Another one, 3x minus 4y minus 7 equals 0. Another basic, general form can be used with all lines, including vertical lines. Okay, so what that means is that slope-intercept and slope point can only be used with linear functions, no vertical lines. So general form is for relations, any type of line. Vertical, where the domain repeats, is okay. But we know for functions, vertical lines are out. So slope-intercept and slope point, we only use those for functions. So general form works for everything. Slope-intercept, slope point only works for some, the functions. All right, so let's work at putting things in general form. So you can see here in A, this is in slope-intercept form. So to put it into general form, we have to move everything to the left side or truly everything to the same side. So the way I work this is I always look at my AX term. Now we want that 3 to be positive, right? So because we want that 3 to be positive, we're going to move it to the other side to make it positive. Plus 3x. Then I'll add 3x over here. See, moving everything to the left, that means I got to move this 5 too, so subtract 5. And then I'll put it in the proper order. So the x always comes first, then the y, so that's a positive 1, and then our constant. So that one was pretty darn easy to put into general form. B. If I look at this term here, I see a couple things. Well, number one, it's already positive, so I don't want to move it. If I move it, it's going to go negative. So let's leave it here and bring everything to it. That's the first thing. And the second thing, it's a fraction, so we'll have to adjust that as well. So let's deal with the first part. Let's get everything to its side because the x is positive where it is. So that means let's just bring the y over. So what I have then is 0 equals 1/2 x minus y plus 3. So remember, the y can be negative, and that constant, the 3, it could be negative too if it needed to be. It's just the x term that has to be positive. All right, so we've dealt with that. Now we got to get rid of the fraction. To get rid of the fraction, multiply by the denominator. There's only one fraction here, so we have to multiply by the denominator. If there's multiple fractions, we would multiply by the lowest common multiple of those denominators. So this means I'm going to multiply everything by 2. So what's 0 times 2? 0. Half times 2 works out to 1. So I could just write x, but I'll write 1x for you guys. Negative y times 2 is negative 2y. And positive 3 times 2 is positive 6. Now, the x is positive. Everything's on the same side. It's kind of in that reverse order. So what we can do is we can simply flip-flop and just write everything over on that left side as well. And there we go. Now these are in slope point form. So the first we have to do in slope point form is we need to get rid of the brackets. So I'll have to multiply the 2 through. Okay, and now why do I have to get rid of the brackets? Well, general form doesn't have brackets, so I got to get rid of that. Equals 2x plus 2. Now we're going to start shuffling everything to one side or the other. Again, the x is positive where it's at. So I'm saying let's leave it there and bring everything to it. I'll subtract y. And I have to add 3. Or add 3. So remember, we always do the opposite to move something to the opposite side. So 0 equals 2x minus y plus 5. The 2 and 3 make 5. And then again, we can just flip-flop it and move it to that other side. We could subtract them all over there if we wished and then multiply by -1 to change the signs as well. But I think it's easy just to do what I did there. We're just using a pattern to our advantage. Okay, in D, so we have brackets to get rid of, but we also have a fraction to get rid of. So the first thing we get rid of is the fraction because I don't want to multiply. I don't want to distribute the negative 3 in. I don't want to do, or the negative 1/3. That seems messy to me. So I'm going to multiply by the denominator of that fraction, which is a 3. And remember, like we talked about in the previous video, that I'm going to multiply everything by 3 that's not already in brackets. So 3 times y is 3y. 3 times 2 is 6, positive 6. Negative 1/3 times 3 works out to negative 1, people. And then in brackets, x minus 4 would remain unchanged. So now this question looks just like this question, and I just carry on just like that. So now I would distribute. 3y plus 6 equals negative x plus 4. My x is negative, so that means I want to move it. I want to move that guy, so I'm going to add x. Add x, subtract 4, subtract 4. That would cancel out this side. So now I get x plus 3y plus 6, and it equals 0. Okay, so it's pretty easy to write things in the general form. And again, here's the summary for that. You can pause the video if you need to. Example 2. Find the slope of the line presented in general form. Okay, so in general form, there is a way to find the slope if we want to do kind of a bit of a calculation, but the easiest thing for ourselves is just rearrange it into something that is easy to find the slope already. So if I could rearrange these into, say, slope-intercept form, then it would be really easy to find the slope. So that's what we're going to do. So for slope-intercept form, right? With that slope. So I'm going to get the y by itself. To get the y by itself, I have to actually get the y term by itself first. So meaning I'm going to subtract 4x, subtract 4x, and then I have to add 12, add 12. I do the opposite to move those things. So I get negative 4x plus 12. Oh, I'm sorry, I can move that in order. I have negative 3y equals negative 4x plus 12. And then now I want y by itself, so I divide by whatever's in front of it, which happens to be negative 3. I divide everything there. So y equals 2 negatives make a positive, so it's going to be a positive 4 over 3x now. Positive divided by negative would be negative, so negative 4. Here is the same line, but now expressed in a different form. So now it's slope-intercept. And then from here, I can see really easily that my slope is equal to 4 over 3. Okay, B, same idea. We want to try to get this y term by itself first, so I'm going to have to subtract 2x away, and I'm going to have to subtract 20 away. So negative 4y equals negative 2x minus 20, and then now I simply divide by negative 4. So it's a pretty easy process to convert general form into slope-intercept, and that's why I'm suggesting to do it. Convert it to slope-intercept because it's quick, and then you can determine the slope, half. Example 3, graph the following lines. Okay, so we know a bunch of ways to graph. We can use table of values, we can use intercepts. If we have slope point, then we'd use our slope point method, and if we had slope intercept, we'd use the intercept and the slope, which is really just slope point. So we have a bunch of different ways to do it. With general form, you could go table of values, but I suggest using the intercept method. So there are other ways to do it, but I think this is just straightforward. We could also, convert the form like I was kind of referring to before. If I put this into slope point, I could graph it like a slope point equation, but let's leave it as is. Let's go. So 4x plus 0 minus x equals 0. So now then I just add 8 to the other side. So I got 4x equals 8, divided by 4, divided by 4, x equals 2. In the second one now, x equals 0, so I'm going to say 4 times 0 plus y minus 8 equals 0. That's done. That means I can move this guy over, add 8, y equals 8. There we go. These are my two intercepts. So then now, so this would be step 1. Step 2, I'll just sketch it. 8, 1, 2, 3, 4, 5, 6, 7, 8. And then x is 2, 1, 2. And with a straight edge or a ruler, I would draw that line. I'm sorry, I'm drawing mine freehand. And then I like to, whenever I sketch, whenever I don't have an actual piece of coordinate plane to work with when I'm drawing it myself, I like to write the coordinates down. So this would have been 0, 8, and this would have been 2 and 0, just in case my picture is kind of messy and ugly. Someone can see what I'm trying to do. Okay, let's do it again. So you could convert it, but why? Let's just use the Intercept method. So I'm going to get 6x plus 3 times 0 plus 3 equals 0. That is 3 times 0 is 0, so it's gone. Subtract 3, subtract 3. 6x equals negative 3. Now divide by whatever's in front of x. X equals negative 1/2. Now, that's a really common error. A lot of people would have divided by that 3 because we kind of want to make nice, easy divisions. So people know 6 divided by 3 works out to 2. So watch that. Make sure you divide by whatever's in front of the x, not just what would be nice to divide. So that's negative 1/2. Y equals 0. So 6 times 0 plus 3y plus 3 equals 0. That's gone. 6 times 0 is 0, so it's gone. Subtract 3, subtract 3. 3y equals negative 3, divide by 3, divide by 3. Y equals negative 1. So again, that's my step 1. Step 2, graph it, sketch it. Y is negative 1. Oh, sorry. Y is negative 1, which is down here. X is negative 1/2, which would have been right there. And then I draw my line through. And again, I like to write my coordinates in when I sketch just to make sure somebody knows what I'm trying to express. And I could express that as a decimal if I wish to, however you want to do that. All right, everybody. So that was a short one, which is good because the last one was super long. But that's general form, so it's pretty easy to work with. And remember, it works with any type of line, so vertical included, or slope point and slope intercept, they only work with functions, meaning we would never use them to express a vertical line. All right, so if you're having trouble, go talk to your teacher or come find me. Have a great night.